right, hello everybody. We are going to talk about the Vertex work of art today. The Vertex work of art, you know, is due tomorrow, and it deals with finding the vertex in a general form of a parabola. So here we go. We've got our general form of the parabola, y equals ax squared plus bx plus c. And now what we have to do is we have to complete the square to put this sucker into vertex form. So let's check out how we would do that. We had that pesky a out in front, and so what we can do is just divide everything by a. I know on Thursday we kind of talked about how to do this in class. So we can divide every term by a. Now certainly when we look at this first term to the right of the equal sign, we have an a divided by an a, leaving us with just this equation right now. The reason we're dividing everything by a is we'd like to get a lead coefficient of 1. Once we have a lead coefficient of 1, life is a lot easier when it comes to completing the square. So next what we would have to do is get the x squared plus this b over ax all by itself. Because what we're trying to do, remember, is get everything away from this guy that we want to complete the square. Therefore, we are subtracting this c over a from both sides of our equation. Keep in mind over here now we had the plus c over a. We wanted to get rid of it. So when we subtract c over a from both sides, we end up with this equation, y over a minus c over a equals x squared plus b over ax. Now, you might be thinking, hey, I could probably simplify this a little bit, combine some guys that have a common denominator, and we could, but keep in mind, when we are moving things over to the left, eventually we're going to have to undo all of those. So we're just going to kind of keep it a little messy on the left, knowing that when we move everything back to the right, things will work out kind of nicely. So here we go. Now what we got to do is think, how do we complete the square over here on the right side? What is the number that I could put into the blank so that the right side now is a perfect square trinomial? Well, the technique that we've talked about is we always want to take half of this middle term and square it. Half of the middle term and square it. Half of the middle term and square it. Well, what in the world is half of b over a? Well, keep in mind half of b over a is just multiplying 1/2 times b over a, or b over 2a. Sure, so now we know that half of this middle term is b over 2a. So what we'd have to fill in the blank with is this b over 2a squared. And of course, what we do to one side of the equation, we have to do to the other side of the equation. Therefore, we are adding b over 2a quantity squared, those parentheses are important, b over 2a quantity squared to both sides of our equation. This is keeping our equation balanced. All right, so what we have right now is the right side is a perfect square trinomial. We know that because we completed the square to make this a perfect square trinomial. The left side now is just a bunch of a big mess, but that's okay because ultimately to get this guy in vertex form, we needed to complete the square. Well, keep in mind, we made the right side a perfect square trinomial. Therefore, we could factor that bad boy into this binomial squared. That's what a perfect square trinomial is. It's a binomial that has been squared perfectly. The left side right now is just staying the same, trying to show things step by step. So from this step, all we've really done is we have factored the right side using our facts about perfect square trinomials. Probably want to clean up the left side just a little bit now. This b over 2a quantity squared, just to get rid of any parentheses, we can square the numerator, b squared, square the denominator, 2a squared. So when we square the 2a, we square the 2, square the a, we got 4a squared. So you can kind of see this starting to take shape now, and maybe you're even brainstorming ahead that, all right, well, I've got this guy, which totally is going to give me the x-coordinate of our vertex, but it's still going to need something over here for the y-coordinate of the vertex. And that's where all this left side garbage comes in. Let's get all these guys from the left side back over to the right, meaning we'll add c over a to both sides, and we will subtract b squared over 4a squared from both sides. So this still kind of looks messy, but that's no big deal. We know the vertex form will eventually have like an x minus h squared plus some k, and we'll just have a garbage looking k. That's no big deal. Notice the left side of the equation now still has this y over a. We need the left side to just be y equals. So let's multiply both sides by a. So keeping in mind, what we have to do is we have to multiply every single term by a. Now don't get confused with this binomial squared. This whole big thing is just one term. So we are multiplying that term by a, meaning a is our lead coefficient. This should make a lot of sense because in our general form, y equals ax squared plus bx plus c, y equals ax squared plus bx plus c. A was our lead coefficient. So, of course, we've got this big mess now, and things can be simplified. Like these a's can cancel out, these a's can cancel out. So check it out. Once we have these two a's cancel out, the left side is just y. This is really, really good. This is what we wanted. We still have our a as our lead coefficient. Do not try to distribute this through because order of operations would say you can't do that. There's an exponent. These two a's would certainly cancel each other out. The a that's out in front of this b squared over 4a squared will cancel with one of the two a's in the denominator 4a squared, leaving us with just b squared over 4a. b squared over 4a. Okay, so now all of a sudden, this looks very similar to our vertex form, right? There's a lead coefficient. All that's going to do is affect the height of the parabola. This looks like it could be our x term. This looks like it could be our y term of our vertex. So, hooray, we've got this guy in vertex form right now. Oh, since we have this guy in vertex form, yeah, we can extract the x-coordinate of the vertex and the y-coordinate of the vertex. Check this out. The vertex will just be this negative b over 2a, because remember, inside the parentheses we're doing the opposite, comma, this whole big chunk of y-coordinate, c minus b squared over 4a. So we've got our vertex now. We've got our vertex to just be negative b over 2a, comma, c minus b squared over 4a. Now, certainly this y-coordinate looks like, hey, I might be able to simplify it. Maybe you're thinking to yourself, we have a denominator, so it'd be better to write this as one fraction instead of two fractions. Totally. We could do that if we wanted to, but for the purposes of this exercise, we really just wanted to be able to manipulate the standard form of a quadratic equation, make that sucker into vertex form, and get our vertex. All right, hope this helped with your work of art. I'm looking forward to reading them, and everybody have a wonderful day.